Yes, Daniel, do you want to revise any topic, any concept, any lab?
No, not at the moment, not off the top of my head.
So today our major topic is IPv6. And apart from IPv6, all concepts are the theory part. For example, like QoS, SDN, licensing, all these are the theory. So once all the contents are done, then we'll discuss about some questions. Okay, I will tell you regarding some questions which comes maybe in your exam, or maybe similar type of question will be in the exam. Yesterday we discussed about triple P. In triple P, we discussed about how triple P encapsulation, like enabling the triple P encapsulation. Then we discussed about the authentication. In triple P, we had two type of authentication, PAP and CHAP. Yesterday we verify CHAP and PAP authentication. One more functionality in triple P is multi-link. Now, multi-link is similar to your Ether channel. Ether channel is a technology to combine the multiple Ethernet link, whereas multi-link is a mechanism to combine multiple serial link. For example, if we have these two routers, to multi-link, you can combine these two links, and logically again they will represent as a single logical link. So now multi-link combine multiple physical serial link into a single logical link. Bandwidth will increase by default on the serial link. The bandwidth is 1.544 Mbps. So if you combine these two, so there will be 3088. Maximum 10 links can be bundled in a group. You will get redundancy. If your one link goes down, no issue, you have another link, your communication will not drop. You will get load balance. Multi-link work with triple P encapsulation. So how to configure the lab? So let's say we have these two routers. So to configure multi-link, first thing is you have to enable the triple P. So let's see the configuration task. I will write all the commands in on that screen. Okay. So first thing, we have two interfaces, interface serial 2 by 0 and 2 by 1. So first thing, no IP address. On the physical interface, no need to assign any IP address. Then you have to define encapsulation triple P. Then triple P multi-link. This command will enable the multi-link feature on the particular serial interface. After that, triple P multi-link group and group number 1. So it is giving that message, multi-link group interface does not exist. Please create the interface first. So what you have to do, you have to create a interface multi-link. Interface multi-link 1 triple P multi-link group 1, and you have to assign IP address to that multi-link, not to the physical interface. IP address, let's say 10.0.0.1 and no shift. Exit. So once again you have to go to the serial 2 by 0 and again run that command. This time it is not giving any error message because we create the multi-link, and then no shift. So what command I enter here, do show history. So I run all these commands. Same command you have to write for interface serial 2 by 1 on this router. So here you have to run all these commands and no shift and exit. See the configuration carefully. So first thing on R1, I enter into the serial 2 by 0. Then there I define no IP address. Encapsulation is triple P. Then I define I want to enable the triple P multi-link. Then I'm defining what is my multi-link group number. If you remember in Ether channel, we are defining that command, na, channel group and then number. Remember? Channel group, number, then mode, desirable or auto, right? So same type of configuration is here. Triple P multi-link group number. Same configuration in 2 by 1. And then you have to define IP address to this interface. On R2, configuration will be exactly same. Just you have to change the IP address. So let's say on R2, I run all these commands. So if I run the command show IP interface brief, these physical interfaces are up, but that multi-link is showing down. Let's wait for a few minutes. Our configuration is correct. Show IP interface brief. Here is up. Let's say show run. So here is not showing one command. Interface serial 2 by 0 triple P multi-link group 1. No shut. Interface serial 2 by 1. Everything is up now. Yeah, because we copy and paste now. That's why sometimes it is not taking all the commands.
So sometimes when you do that copy and paste, it doesn't work. So you really should do it manually.
Yes, sometimes. See here, maybe the issue is with the because I'm copying from this GNS3, right? But normally, whenever we are copying, we have a complete script, right? We are running that script basically. That command is here. I write that command. Okay. So now let's verify. So first thing, let's try to communicate 10.0.0.2. I'm able to communicate. Remember, there is no IP address on the physical interface. The IP address is on the logical interface. Show interface multi-link 1. So if you see here, your multi-link is up, line protocol is up. See here, the bandwidth 3088. By default, the bandwidth on one serial link 1544 kbps. Clear that thing? Your bandwidth is increased right now and you are able to communicate. Any question in this topic?
No, not at the moment.
This is your multi-link. Regarding the multi-link, there is a activity. Let me see the discovery number 48. Try to perform that activity. Discovery 48.
48. Got it.
Triple PoE means point-to-point protocol over Ethernet. Triple PoE is configured as a point-to-point link between two Ethernet ports. So if you configure triple PoE on Ethernet ports, so you will get the functionality of triple P. For example, like you will get the authentication feature. In cable network and DSL, digital subscriber link internet connection, ISP inform their customers to set their router to receive IP address from them using username and password. So if you configure triple PO in cable network or DSL network, ISP inform customer to set a username and password. So once he log in with the username and password, the device will get IP address from the ISP. So ISP treat their customers router as triple PoE client. It allow virtual point-to-point connection over multi-point Ethernet network. multi-point Ethernet network, for example. This is your PC, CPE. CPE is customer provider edge, or you can say it's a customer router. ISG, Internet Security Gateway. And here is my, let's say, AAA server. So this network will be ISP network. So here you will create the username and password. This PC will log in with the username and password. And from here to this router, you have to configure PPOE. So PPOE is a protocol that is used by ISP to provision DSL line high speed internet service. Because on the serial link we will get only 1 Mbps speed, and if we have fast Ethernet, we have gigabit Ethernet network, we can get 100 Mbps or 1000 Mbps speed, of which the most popular service is ADSL. ADSL modems. So service provider can use the same authentication server for both PPP and PPPoE session, which result in cost saving. PPPoE use a standard method of encryption, authentication, and compression of the data. So this is the PPPoE. Here, what will be the server configuration? That is not our part. In CCNA, you have to just deal with how you have to configure PPPoE as a client. So for that, there is a discovery number 49. Try to complete that discovery, configure and verify triple PoE client.
Got it, 49.
Yes. Through SNMP, you can monitor the device, you can manage the device, you can get alert and log message on the SNMP. Monitoring in the sense, let's say in my data center, I have 100 of devices. Those devices are running 24/7, right? So maybe in some device, the temperature is very high. This CPU processing is 100%, right? If temperature is high, CPU performance is 100%, then there can be a hardware issue. Maybe some ports will burn, maybe motherboard will damage, right? So if you have any management software and if you configure SNMP on the device, then if something happened to the device, then the alert message will go to the SNMP server. Like in the management point of view, you can configure some devices with the help of SNMP server also. SNMP work on UDP port number 161. SNMP component. In SNMP, basically we have three components. First component is manager. Second, agent. And the third one is MIB, management information base. So who is the manager? Where we install SNMP server. The PC where we install the SNMP server. Agent, devices where we enable SNMP service. And MIB, management information base, database of agent. So if you configure SNMP service here, so it will become agent, 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 and this will become manager. Every agent is having a MIB, management information base. SNMP version. We have three SNMP version. SNMP version 1, version 2, and version 3. SNMP version 1. In SNMP version 1, there is no security. There is no security feature. Second point, you can get information one by one from agents. Let's say in your data center you have 100 devices. So through SNMP version 1, there is no mechanism you can get the database of all 100 devices at the same instance, same time. You have to take the information one by one. Then we have SNMP version 2. In SNMP version 2, again, no security, but you can get information from multiple devices or agents at the same time. Next is SNMP version 3. In SNMP version 3, security introduced. So in security, there are three kinds of security. First is no auth, no pre. No auth, no pre means no authentication and no privacy. Here privacy means encryption. Then second one is auth, no pre, and third one is auth pre. First thing, no auth, no pre, no authentication required, no privacy required. Means there is no requirement of authentication and privacy. Second one is auth, no pre, means authentication is required but privacy is not required. Means whenever you access the database, access the MIB, in that case authentication is required, means to whom you are to which device you are getting the database, but privacy is not required. Privacy means encryption is not required. And third security is auth and pre, means authentication is required as well as privacy is required. So how to configure SNMP? So to configure SNMP, you need a SNMP server which you have to install on any PC. After that, you have to create a ACL to select network, means you have to select the internal devices. Then second one, create community. Community will be RO read only and RW read and write. So those community must be same on the SNMP server also. Then third one, configure trap receiver. Fourth one, configure SNMP version 3 user. This fourth step is not required if you are configuring version 1 and version 2. But in version 3, you need SNMP version 3 user account also. So normally you have to create a access list. You have to create a community. You have to create a trap receiver. Trap receiver means who is your SNMP server. So let's say I'm configuring this on the switch. Let's say I create a access list 100 permit IP 10.1.1.0 and any this is the port number, any port number. Here I'm not defining EQ80 EQ like this way. I'm defining all the port numbers. Then you have to define the community SNMP server community. So let's say I create a community named Cisco, and that Cisco is having RO rights, read only rights, and this 100 is this ACL number. SNMP server community, let's say ABC, another community which is having read and write rights, again 100. This 100 is again the ACL number, and last one is SNMP server trap, let's say 10.1.1.50. This is the SNMP server IP. So if you configure these 4 commands on all the devices, what it will do, if anything happened to the device, it will send a trap message to the SNMP server. For this, there is a discovery number 53. Try to perform this discovery. 53.
Me.
Next, IPv6.
Also, your files came across.
Sorry?
The files that you sent us,
Yes.
they came
Have you
across.
received? Have you received them?
Yes, I have.
So just download. Don't install that particular software. I will instruct like how to install that thing, because if you install and if crack is not working, then you are unable to open the files. There is a crack in this software. Okay.
Okay.
IPv6. Till now, we just discussed about IP version 4. We completed IP version 4 routing, IP version 4 security. So now, whatever we done on IP version 4, we have to do on IPv6. And there is a lab in your exam based on the IPv6. So, firstly, let's discuss the theory part. IPv6 is 128-bit long. Divided into 8 octet. Each octet having 16 bits. Octet separated by this double colon. Loopback address no subnet mask used. Only CIDR notation. CIDR notation means slash and then network bits. Let's say slash 24, slash 26, slash 20, 64 like this way. Transmission mode in IPv6. So in IPv6 we have unicast, we have multicast, but in IPv6 we don't have any broadcast. Instead of broadcast we have a new thing which is anycast. So we'll discuss this thing, what is anycast. Features of IPv6. First, larger address space. If you count total number of IPv6, then 2 raised to power 128 minus 2. So whatever value you will get, that will be the total number of IPv6. So if we start giving thousands of public IP address to a single user, till next 500 years, this IPv6 not finish. That much of IP addresses we have. Assume 2 raised to power 128 means 2 into 2, 2 into 2, 2 into 2. Like this way you have to do till 128 times. Then no need of NAT. NAT is not required. But if you want to do, you can do NAT, and that concept is known as NAT-PT. Simplified header. IPv6 header is very simplified, right? I will compare those two header, IP version 4 and IP version 6.
So what's the reason that NAT is no longer required?
Because we have that much of public IP addresses. We are doing that because in IP version 4 because we have the shortage of IP addresses. But here in IPv6 we have thousands of IP addresses which we can give to a single user, and those IP will not finish. But if you want to do, then there is a concept of NetPT. No broadcast. Broadcast is not required. Stateless auto configuration. Stateless auto configuration means in IP version 4 we have two methods to assign the IP address. Either you can provide static IP or you can provide IP address by DHCP. But here we have another option, stateless auto configuration. Stateless auto configuration means if you don't have any DHCP, in that case also you can assign automatic IP addressing. Inbuilt security for mobility. By default support for IPsec and mobility. You can assign multiple IP on one interface. So these are some properties. Next, IPv6 transition tool. Remember this point, that will be in your exam. How many methods are there for the translation? So we have dual stack, second one IPv6 to IPv4 tunnel, also known as 6 to 4 tunnel, and the third one is NetPT. So these are the three options through which you can communicate IPv6 to IP version 4 also. For example, let's say in your organization there is a new site. That new site you can configure with IPv6, but internet is still running on IP version 4. So inside your network you have IPv6, outside the network you have IP version 4. Then how you will get the internet access? So you have these three transition tools. You can use any tool. Dual stack means on your router you can define IP version 4 as well as IPv6. Then you can configure NetPT, or you can configure a tunnel 6 to 4. Clear this thing? Any question here? IPv6 address type. So firstly we have unicast. So if you remember, in IP version 4 in unicast we have public and private. So same way here we have unicast. In unicast we have global unicast, We have unique local and we have link local. Global unicast is like public. Private. And this is APIPA. Global unicast IP start from 2000:/3. So means IPv6 address which start from 2000 series, that will be a public IP address, global unicast address. If any IP start from FC00, that is the unique local address. APIPA FE80::10. This IP is link local address, like your APIPA. Second one is multicast. Multicast IP start from FF00:8. Clear this thing? Then we have some special multicast address. For example, one, this is for all nodes, or you can say PC on a link. This is all routers on a link. This is for RIP-NG. RIP in IPv6. OSPF in IPv6. EIGRP in IPv6. Next type is Anycast. Anycast. Anycast IP used to resolve a request by nearest one server. Any IP can be any cast. What will be the command? I will show you that thing. So it's like this way. Let's say here is some user. So if this PC send any request, this is the web server, this is the web server. So if you configure whatever IP address is here, that IP as a anycast. So what will happen? This request will go to this here, this router. This router will see who is the nearest server. So based on that, it will forward the request to that nearest one server. Those servers having the same IP address. In IP version 4, same IP cannot be assigned to the two machines, two servers. But here, if you define as a anycast IP, you can define that IP as a another machine IP in another machine also. That is the meaning of anycast. Next point. How IPv6 looks. IPv6 writing rules. In IPv6, we have three golden rules. First, you can remove leading zeros from left side. If you have continuous zeros, then you can replace zeros with this double colon. Third point, this double colon can come only once in IPv6 address. Read these three statements carefully. If you have any doubt, then let me know. There will be one question on these three topics, means in these three statements. You will get a IPv6 address and you have to simplify that IPv6 address. So let me give you an example here. Let's say we have a IP address. This is the IPv6 address. 8 digit, 8 octet, 128 bit. Now, see carefully. If I apply these three rules in this IPv6 address, so this will be 2000. I can remove this leading zero. So it will become like this way. Either I can replace these 0 or these 0. So if I am replacing these 80 with a double colon, So here in this stage, it is more scalable. So now after this 2A00. Now this double colon I already used, so I cannot use here to remove this continuous 0 in a octet or in a block. So what I can do here, I can remove these 3 leading 0 and 1 0 will be as it is. So that will be the final result. Ask any question if you have. Yes, Daniel, Rick, any question?
No questions. But you said they're going to speak about the IPv6, specifically about the writing rules or something about solving.
There will be one problem which you have to solve in IPv6. I will tell you which one is this.
Okay.
I will solve that one. Don't worry. Next thing. How many ways to assign IPv6 address? So we have one static method. We have one DHCP. Here DHCP is known as stateful. Third will be stateless autoconfig. This is EUI64 method. So we'll discuss this thing, what is EUI64. So static is manual method via DHCP, and third one is the EUI64. So I'm going to discuss EUI64. EUI64. EUI is extended unique, or sometimes called universal identifier. Now, EUI64 is a method to assign IPv6 address with the help of MAC address. MAC address, physical address. So if you see, this is 64, but MAC address is 48-bit. Then how you will make it 64? Because we need a 64 IP address. So for that, what you have to do? Let's take first any MAC address. So let's say my MAC address is 24.46.2A15.56. Let's say this is my MAC address. This MAC address is 48-bit, but we need a IPv6 address of 64-bit. Then how to make it? So that UI64 address generate automatically. We have to just learn the process, how it will make. So in first step, MAC address is 48-bit long, but we need 64-bit address. So for that, we add FFFE. This is the 16-bit field. 16-bit in the middle of MAC address. If we put this field into the middle of the MAC address, so what will be the new MAC? So 24, that's a 46, 2A, FF, FE, 15, 56, 25. So that will be the new address. So this is the 64-bit. In step number 2, so firstly you have to add these 16-bit into the middle of the IPv6 address. So once you add, FFF FE in MAC, convert that hexadecimal value to binary. You have to convert that hexadecimal value to the binary. Third point, once binary conversion done, then change 7th bit from left side. Change 7th bit means if the 7th bit is 0, then put it 1, and if it is 0, then put it 1. After changing 7th bit, again convert into hexadecimal and you will get IPv6 address. So this is the step. Your router will do this process automatically. No need to do this thing. If you want to verify, then you have to follow this process. IPv6 configuration. So in IPv6, let's say we have these two routers, R1 and R2. Here I want to assign IP address. Let's say here is colon 1, here is colon 2. And my subnet is this is my subnet. This is subnet and this is the IP address. So how you will assign? So first thing, on R1, we will go to the interface. Let's say this is the fast Ethernet 0x0. Interface fast Ethernet 0x0. And there, instead of IP address, you will write IPv6 address. That is the change. And then 2001 colon 22 colon 22 colon A colon colon 1/64. That's it. That /64 represent the subnet mask. And after that, no shift. That's it. If you are on R2, interface fast Ethernet 0x0, then you will define IPv6 address 2001 colon 22 colon 22 colon A double colon 2/64. No shift. And exit. If you want to verify, for example, in IPv6, we have a command show IP interface brief. Here the command will be show IPv6 interface brief. If you run only show IP interface brief, that will give you only IP version 4 information. If you want to see IP version 6 information, then show IPv6 interface brief. One more thing.
So basically the commands are the same. You just have to insert IPv6 in front of everything.
Right. All command, whatever command you run with the show IP in IP version 4, just replace with IPv6. That's it. All command will work. For example, show IP interface brief, show IP OSPF neighbor, show IP EIGRP neighbor. So show IPv6 OSPF neighbor, show IPv6 EIGRP neighbor, like this way. Show IP route, show IPv6 route. To enable IPv6 routing on device, you have to run, let's say on R1 or R2, you have to run a command IPv6 unicast -routing. So once you enter this command, then only IPv6 routing will be start. Clear? Any question here? Read the configuration carefully. Yes, it done. Completed. Yes, Krick, any question here? Daniel?
No, no questions from me.
Next one is IPv6 static route. So if you remember IPv4 static route, the command is IP space route, then destination network, then subnet mask, and then gateway, right? Let me write here. And IPv4 command is IP space route, then destination network, then subnet mask, and then default gateway. Clear? That will be the syntax. Syntax will be exactly same in IPv6. So let me show you one example. Let's say these will be my IP addresses. So how to assign IP address, that I already discussed. I'm just writing the static route. So if you go with the R1, for R1, this route is the destination because this and this is directly connected. Same way for R2, this is the destination network. So how you will write the route? So on R1, first command IPv6 unicast -routing. So that routing will be enabled. Then IPv6 route. Then destination. This is my destination. 2000:20:20:, sorry, /64. You have to give the network ID. So this is the network ID. .1 is the IP address. Then subnet mask. In IPv6 there is no subnet mask. And gateway, if you want to reach in this network, this IP will be your gateway. So 2000:12:12. Like this way. If you are on R2, same command, you have to just change the source and destination. IPv6 route, and here my destination is 10:10:A64. With the gateway, there is no requirement of / value. So this is your static route. If you want to verify, you can run the command show IPv6 route. Clear this thing? Any question here?
No, not at the moment.
On IPv6, there is 2 discovery right now. Discovery number 28 and 29. 28 is how to assign IPv6 address on the devices, and 29 is how to configure IPv6 static route. So try to perform those 2 activities. 28 and 29.
Discovery 28 and 29?
Right.
Okay, I'm going to step off. I need to go to the restroom real quick.
You have to initialize the RIP with any process name. It can be any name. After that, you have to run that process inside the interface. So let's say there is interface fast Ethernet 0/0, loopback interface 0/0. So you have to just enable this command, enable the RIP inside the interface. So automatically whatever subnet is present there, that will be automatically advertised into the RIP. And if you want to verify, you can run show IPv6 route. So on that, there is a discovery number. On IPv6 RIP, there is no lab. EIGRP and OSPF feature. Okay, not an issue. So you can note down this thing. Next, EIGRP. So EIGRP in IPv4. So what is the command? Router EIGRP and then AS number, let's say 100. And inside that we are defining the network, right? EIGRP in IPv6. So here, first command will be same, IPv6 router EIGRP and 100. Before that you have to run IPv6 unicast routing, unicast -routing, and after that you have to run this command. Now once you run IPv6 router EIGRP, by default EIGRP process is shut down. So inside that you have to define no shut, first thing. And there is a router ID which you have to define there. So let's see. Let me see what is the command here. I think so. EIGRP router -ID. After that, same way, you have to go to the interface fast Ethernet 0/0 and IPv6 EIGRP AS number. Clear this thing?
Yes, that makes sense.
To verify EIGRP, so same way, show IPv6 EIGRP neighbor. You will get the neighbor information. Show IPv6 EIGRP topology. Show IPv6 route. So So this is the discovery number 41. Try to complete this discovery. 41.
41. Got it.
OSPF in IPv6. So if you remember how we are configuring OSPF in version 4. First thing is router OSPF 1 will be the process ID. Then Inside that we are defining network. After network, wildcard mask. After wildcard mask, we are defining the area and area ID. So same type of configuration is there, and on your exam there will be one lab on this topic, OSPF in IPv6. So let's assume this is ISP and here is a default route. And this network is IPv6 OSPF. So in this there are two tasks. One, you have to configure IPv6 OSPF, and I need this IPv6 default route inside my OSPF. Two tasks, and these two tasks will be in your exam. So how you have to do? First thing, on R1 and on R2, IPv6 unicast hyphen routing. Second command, let's say this is my R2 and this is my R1. After that, IPv6 router OSPF 1. 1 is the process ID. Inside that, you have to define a unique router ID, router hyphen ID, and that ID can be any IP version 4. So let's say here I'm giving 1.1.1.1. Any IP version 4 IP address you can give as a router ID. Then exit from there. After that, go to the interface. Let's say fast Ethernet 0x0. Let's say this interface is 0x0. IPv6 OSPF 1 area and area ID. Clear this part and exit. Now, so this is the OSPF configuration. If you want default route in IPv6 OSPF, in that case, what you have to do? IPv6 OSPF, sorry, IPv6 router OSPF 1. Inside that, you have to run a command default information hyphen originate. That's it. Clear this thing? So try to perform discovery number . This is the discovery number 45. So try to perform that one. 45.
45. Okay, that's complete.
This will be lab in your Ccna exam. IPv6 OSPF SIM. Read this question carefully. This is your diagram, and based on that, then we'll discuss about the solution. So first thing they are telling, all routers are running IPv6 OSPF with the process ID 100. So in my example, I am taking 1, they are taking 100. The loopback 0 IP address is the OSPF router ID of the each router. Means they are configuring some loopback on each and every router, and that IP address will be the router ID, OSPF router ID. On HQ router, this middle router, a provider link is provided, and you have configure IPv6 route on HQ. So on HQ, you have to configure a IPv6 route to reach this provider, and make sure the route is advertised into the OSPF. So it's the same way. You have to configure a IPv6 route to reach the provider, and after that you have to use that command. What? Default information originate. Also troubleshoot why the HQ is not forming the neighborship. So in this there are 3 tasks. First task is you have to create a default route. First task. Second task, you have to advertise that default route into the OSPF. Third task, HQ is not forming the neighborship with BR router. 3 tasks. They are giving some additional information. Configure a static route on HQ router with the default gateway this. So default gateway should be this. Verify by pinging this address. So this address may be after this provider somewhere. Let's say this IP is the Google IP address. So on the HQ router, you have to ping this router. This is the activity. Make sure you are typing the ping command, or you are pinging this command IP. Next, make sure that the default route is advertised into the HQ. Okay. The HQ router is not forming. Okay, let's troubleshoot that. So first task, as I told you, to enable the any kind of IPv6 routing, first command will be IPv6 unicast routing. Clear this thing? If you want to configure a IPv6 route, then IPv6 route :0. This represent default route in IPv6. Normally in IP version 4, we are writing 0.0.0, 0.0.0, and then gateway. So here instead of 0, all 0 will become :/0. Getting this thing? And this gateway information they are giving into the question here. The default gateway will be this. This is your first task. Any confusion in this first task? Ask any question if you have. Yes, Chris, Daniel, any question on first task?
Not at the moment.
Okay. Second task, they are telling you have to verify ping on this address. So simply you have to run this ping command, ping IPv6 and that particular IP address. So if your static route is, default route is working fine, then you are able to ping. This is your task number 2. Third task, they are telling you created a static route, default route, and you have to advertise that route into the OSPF. So for that, you have to go to the OSPF, IPv6 router OSPF, and there you have to run the command default information originate, which I told you, right? Any issue in task number 2 and 3?
No, not at this time.
Okay. Last task, they're telling HQ router and BR router, they are not forming the neighborship. If they are not forming the neighborship in OSPF, there can be 5 reasons. First, area ID is not same, subnet ID is not same, maybe authentication is applied and that is not matching, means username and password is not matching. Stub area flag must be same. So here in this, what they are doing, they configure OSPF on both the router, but they haven't advertised OSPF on this particular interface serial 1/0. If they are not advertising this interface as a OSPF, that neighborship will not form. So you have to go to the particular serial interface and you have to run that command IPv6 OSPF area 0. Clear this thing? Any confusion?
No, I'm good.
Good. So whatever mail I sent you, the name is CCNA dumps. Extract that folder. In that folder, there will be IPv6 OSPF SIM packet tracer file. Try to solve this solution. Check. Now, next thing is licensing. Licensing for the services.
Hey,
So
Rick.
whenever, yes, any question?
Yeah, sorry. The next 3 topics, do they need to all run together?
No.
Okay, I was just making sure. If they all need to run together, we can go ahead and take lunch. If not, then we can push.
So that's why I choose this licensing part. Licensing is a small portion because if
Okay.
I start the QoS, that QoS is a big topic, right?
Understood.
So I just took this last option. So licensing is for the features. So let's say if you are taking 2600 series router, 2800 series routers. So there will be one license for the services. But if you go in advanced devices, for example, like Catalyst devices or Nexus devices or some advanced higher end switches, for every service, there is a separate license. For example, if you purchase Nexus 7000 series switch, so in that, there will be a base license. Base license is for the basic functionality. If you want to enable MPLS, if you want to implement VPN, in that case, there will be a separate license. If you want to run HSRP and other redundancy features, then there will be a separate license. If you want to configure routing, in that case, there will be a separate license. So license is required for the services. Now, so for the license, what you have to do, whenever you purchase a device, then you have to purchase the license from the Cisco. Or there is a software, Cisco License Manager. You can install that software. That will be like your call home service. You have to register your product and then you can put the license key inside this and it will bind your device with the license. So first step, purchase a package or the feature from the Cisco. You will receive a PAK file, then obtain a license. You will receive the license key and then you can install that license on the device. Licensing overview. So license can be IP based, can be data, can be unified communication, can be security. So IP based means you will get entry level iOS functionality. Means you
Hey,
can
Rakesh,
figure. Yes.
you know you're not sharing your screen?
Ah, sorry.
Sorry, I just thought you were talking base level before you started.
Not issue. So licensing overview. So firstly, you have to purchase the license from the Cisco. Second thing, Once you have a license, then you can use this license manager or license portal, Cisco license portal, to obtain the license or to register your license with the product. Once you have done task number 2, then you can install that license on the device. What will be the command that we will discuss now. So we have various iOS categories. For example, like IP base, data, unified communication, security, advanced enterprise. So there are different iOS versions which require different license. So for example, if you have a iOS which is IP base, then you will get entry level iOS functionality. Entry level iOS functionality means you can simply configure routing part. If you go with the advanced security, for example, like if you want to implement time-based ACL, we implement ACL, normal ACL, right? If I want to implement this particular ACL will apply on that particular time. So this is the advanced security feature, which will not come into IP base. Okay. If you want to filter, let's say particular URL, for example, you want to block youtube.com. That type of functionality will be not into the IP base. So you have to purchase the license according to your requirement. So let's say you want MPLS feature, ATM feature. ATM is a technology here, asynchronous transfer mode, and multi-protocol support. Then you have to purchase a separate license. Unified communication, in this license you will get basically VoIP feature, voice over IP features. If you go with the security license, in that you will get all the security functionality, all advanced security functionality. For example, like you can configure your iOS as a firewall, IPS, intrusion prevention system. You can configure IPsec, 3- and VPN. 3- is the encryption mechanism. So advanced VPN you can configure, for example, like Flex VPN, IK version 2 VPN. So services depend on the license.
So are these separate licenses or are they separate levels of the same license?
No. There is a license. There is a iOS version. For example, not this. Show version. If you see, this device is having advanced enterprise services. Advanced enterprise service. So if I want the full functionality of advanced enterprise, I require the license for this. Advanced enterprise means this iOS having the capability of all the functionality of MPLS, BGP, ISIS protocol, means the services which is required for the service provider. Okay, so you have to see what iOS you have and which version you have. Based on that, you have to purchase the license. Not based on the model. Based on the iOS version, you have to see. So here some commands will not work. So if you want to see what license are installed, you can run the command show license. So it will show you like IP base K9 licenses installed. What is the lifetime of that particular license? It's a permanent license or for the particular time period. The license state is active and that is in use or not. You have security license or not, IP based license or not. So iOS will be same, but on that iOS you are putting licensing. So based on the licensing, services will be started into the iOS. Clear this thing? No. So permanent license. If you want to install a permanent license, this is the command. So license install this flash, you are putting that license key into the flash and you are installing that thing. First task, you forward that license key into the flash and then you are running this command license install, and from where you have to install? From the flash, from this particular file. Once you install, you have to reboot the device. So command is reload. Any question here? Simple straightforward statement. You have to use license install command. Evaluation license. So evaluation license is for the specific time period. If you want to verify some services, then on the Cisco website there is a evaluation license that will be valid for 120 days. So for 120 days you will get all functionalities. If that particular time period expire, then all functionality will be disabled. So you can download that license from the Cisco portal and then you can install that thing. In this, they are using license boot modules C2900 series. This is the router series. Technology package UK9. And then reload. So whatever functionality will be there in this technology package, those will be enabled on the R1 router. How to take backup? So you can use this command license save and where you want to save that particular license. Right now that license is saved into the flash. If you want to forward into the TFTP server, license save TFTP. After that it will ask the IP address and you can give the TFTP server IP address. That license file will be there into the TFTP server, so that whenever you require to restore that file, you can restore from the TFTP also. If you want to uninstall the license, so you can use clear, license clear and that particular license name. Otherwise, you can run this command. You can disable that particular license. License boot module, particular module number, the name of the package, and you can type disable. Either you can disable it or you can clear that particular license. This is Cisco Smart Software Manager, which is used for your licensing purpose. So whatever license you purchase, all information will be there. So let's say anyhow you completely flush the router. You remove the flash. You erase the flash. So whatever information is there into the flash, that will be removed. So your licensing, each and everything is erased now. So if you want to get that information, you can directly pull that information from Smart Software Manager. So your account will be into the Cisco. Whenever you are purchasing any device, you are creating an account and you are giving that device information to that account. And in that account, there is a mapping of your device serial number and your license key. So this is your licensing part. Clear this thing? So basically into the license, what you have to see, how you will obtain the license from the Cisco and how you have to install the license on the device. Here we don't have any license and we don't have any lab on that. Otherwise, I will show you how to update that license. Yes, any question in the licensing part?
No, none for me.
QS will discuss after lunch. So let's discuss about some evolution technology. So first thing is switch stacking. What is this? You have two type of switches. One switch is like in which we have fixed number of ports. For example, like 2950, 2960, 3550, 3560, 3750. These models having the fixed port devices, fixed port switches. You cannot increase the number of ports. We have some advanced chassis based switches which is used as a core switch. For example, Catalyst 4500 switch, Catalyst 6500 switch, Nexus devices, Nexus 7000, Nexus 9000. So these devices are chassis based devices. So Cisco support virtualization also. Virtualization in which sense? Stacking. Stacking means you can increase number of ports in fixed port switches. For example, we have two switches. The model is, let's say, 2960. 2960. On that, you will get two ports. These ports are known as stack ports. So here special cable will be used, stack cable, and they have cross connection. Switch 1 and switch number 2. Now, once you make stacking, these two units become a one single logical unit. One single logical unit means control plane will be same, but data plane will be different on both switches. Control plane means if you make them as a stack of two devices, in that case, if you are enabling RIP, EIGRP, OSPF on any switch, that will run on both the switches. That is the same control plane option. But how to forward the data to the next device, that is my data plane. So that data plane will be different for every device. Clear this thing? Should I explain more on this?
No, that makes sense.
So this stacking technology is on fixed port devices. We have an advanced technology which is known as VSS, virtual switching system. Virtual switching system. In VSS, let's say we have these two boxes, CAT 6500 switch. These are chassis based devices. So in this, These are the enclosure, a simple box. Inside that you are putting the ports. So you had to purchase these cards from the market and you can plug into the device. And you can increase and decrease the ports. If we implement VSS in this, these two boxes will become one logical unit through PSS. So again, the management of the device, the control plane of the device will be same, but data forwarding will be different. Clear? So VSS technology is in chassis based switches. How to configure VSS, how to configure stacking, that is not our part. That is basically in advanced level. Okay. So stacking and VSS configuration is not into CCNP, not into the CCIE. That is the production work task. So stack-wise can join multiple physical switches into the one logical switching unit. Switches are unit by the special interconnect cable, which are the stack cable, and those stack cable are minimum 10 gig cable. The one switch will be the master. The stack is managed as a single object and it has single management IP address on all the devices. These are the some network designing, how you have to design the stack. So here they are making ASW1 and ASW2 as a stack. So if there is no stack, so due to the STP, these links will be blocked because STP is blocking some link. But if you make it stack, so what will happen? These two will become one single logical unit, and after that you can make ether channel between them. So number of block link will be reduced. Like this way. Now API, application programming interface. So normally in the switches or into the router, we have three planes: control plane, data plane, and the management plane. Management plane is how you are accessing the device. For example, you are accessing with the telnet, you are accessing with the SSH, you are accessing with GUI, all these things. So that is managed by management plane. Control plane, when you run the any routing protocol, so your routing table will build. So whatever information is there into the routing table, that is my control plane information. So if you are running show IP route, that is my control plane information. Data plane, whatever information is there into the routing table, the same information will be copied into the forwarding database, and that forwarding database is known as data plane. There is a slight difference between control plane traffic and data plane traffic. In control plane traffic, you will get destination and the default gateway information. But in data plane, you will get destination and the exit interface information. How you will reach to that particular destination, on which interface you will exit to reach that particular destination. Now, when we talk about SDN, software defined networking, in that case, we have three planes: application plane, control plane, and data plane. So application plane is my basically API, application programming interface. So where this API will work, see, there will be some SDN application, then controller, and then network elements. So hold on. So firstly discuss SDN, software defined networking. So let's discuss why we need SDN. Let's say in my network, I have routers, I have switches, I have firewall, IDS, IPS, load balancer. So these are the different devices. If they have different devices, then the programming language will be different. Means to configure the devices, that syntax will be different in all the devices. And if you want to configure, every time you have to configure, connect with the router, connect with the switches, firewall, all the devices one by one. But if you have SDN concept, so in SDN there is a controller. This is the user. He will use some application, SDN application, which I am telling API, to connect this controller. So the user will send instruction to the controller, and this controller is having the information about all the devices. So the user will send information, user will send instruction to the controller, and controller will send that information to all the devices. Clear this thing? In case of Cisco, that SDN is ACI, application specific, application centric infrastructure. Application centric infrastructure. This technology will work in Nexus 9K devices only right now. So that SDN advanced concept ACI will work only with right now Nexus 9K. So there we have a ACI. We will access this controller. Here will be the ACI. This controller name is Epic. So ACI will connect with the controller, and controller will push all the configuration to the devices. So here what benefit you will get? The first benefit is this controller knows all the language. So if you want to implement QoS, let's say if you want to implement QoS, some policy, and you want to implement that same policy on all the routers. Same kind of policy means, let's say I want to give HTTP traffic 128 kbps. This is my policy. I want to reserve this 128 kbps traffic for bandwidth for this HTTP traffic. So that means if any request is coming for HTTP on the devices, then this device will reserve 128 kbps for that particular traffic to go outside. So what I will do, I will create this policy. I will send that template to the controller, and controller will push that template to all the devices. So it will put the same configuration on all the devices. It doesn't matter what is the language of that particular device, because that controller knows about all the language. Once you add these devices to the controller, that controller will get all the information. So through this controller, you can push the same kind of policy onto the multiple devices. First benefit. Second benefit, let's say whatever template you run, that is not working on, let's say, on this firewall working properly. So what you can do, no need to go on this particular device and to remove the configuration. You can roll back that configuration through the device like this way, and that configuration will be removed automatically. Clear this thing? So these are some benefits. Connectivity between user and controller is known as northbound, and connectivity between controller to the device is known as southbound. Clear this thing? So they are explaining the same thing. SDN application to the controller is the northbound, and controller to the network element means your devices is southbound. So here they are giving some example of API, for example, like OpenFlow, NetConf, OPFlax. These are the southbound applications. Cisco Epic EM. Again, this is the controller. Epic EM is a centralized automation of the policy-based application profile of the following benefits. Single point of network automation for the consistency, means you can push the same kind of policy onto the multiple devices. Automation which save time and cost. You can make a script and you can deploy that script through that controller. Open and programmable network devices using the API. So if you have any API, for example, like OpenFlow, Puppet, Chef, so you can use those things. Support for greenfield and brownfield deployment. These are the basically network design. So through this, you can implement ACL, IWAN. IWAN is the intelligent WAN. You can implement the QS policy, user-based policy, zero-touch provisioning to the new devices. Zero-touch provisioning to the new devices means, let's say there is a Blade server, and in that server you configured something, and you have complete backup of that server. Let's say in future that server goes down. So what you can do, you can take a new server, you can plug that new server, and you can put that saved configuration into the new server. Everything will be back. Improve visibility to the network. When you log in with the controller, you will get the complete layout of your network device. For example, when we are making any topology into the packet tracer, we know, okay, this is the router, this is the switch which is connected with the fast Ethernet. So when this controller discover the network, it will give you the same kind of picture, and you will get to know, okay, router 1 is connected to the switch 1 is connected to the which server, everything will be discovered. This is one of the layout of Epic EM. Intelligent WAN. Again, it's the advanced technology. There will be 4 components into IWAN. Transport independent connectivity. Intelligent path control. Intelligent path control means it will automatically detect, okay, which path is my best path. So once you configure any policy on that, Okay, if there will be some delay, particular delay on that particular link, then automatically switch over the path to the another link. Application optimization, you can run any kind of application. Secure connectivity, you can run IPsec on your traffic. For example, we configure the GRE tunnel, right? In GRE tunnel, again, my traffic is going in a plain text form. But if you want to secure that traffic, what you can do, you can implement GRE with IPsec on that. So these are the SDN concepts. Clear this thing?
Will these, have you shared these slides with us?
See, this slide is exactly same in your books. It is just like pictures of your book. So let's say you have a chapter 1. So there is a chapter 1, like in that chapter 1 there are 10 pictures. So in this slide, those 10 pictures are there. Exactly same 10 pictures.
Okay, so the ebook, that's what you're talking about, right?
Right.
Okay.
Okay, so let's take a lunch break. And after that, we'll do the last concept, which is QoS, quality of service. Clear? Basically, quality of service is used to give priority of the traffic. Priority of the traffic means, let's say in your internal network, you have video traffic, you have voice traffic, you have data traffic. So all the traffic is going at the same time and on the same link. So what will happen? Your video data and voice data is bandwidth hungry. So maybe your data traffic will drop and the whole bandwidth is consumed by the video traffic. Second situation, if your video traffic is not getting the enough bandwidth, so what will happen? The picture quality will be not clear, the voice quality will be not good. So in that case, your video data traffic affect. So how to resolve these issues into the internal network? What you can do, you can implement quality of service. So through quality of service, you can define my video traffic is highest priority, then voice traffic, and then data traffic. You can also specify the particular bandwidth on the particular traffic, and that task can be done with the help of quality of service. So quality of service is used to give priority to the traffic. Clear this point?
Yes, sir.
No. Converge traffic characteristics. First thing. In voice traffic, we have small packets. So sometimes the packets are not coming in the sequence. So if the sequence is disturbed, again the data quality will be disturbed. So constant small packet voice flow competes with bursty data flow. Critical data must get higher priority. Next one, voice and video are time sensitive. Now, if there is a delay into the voice, again, the quality will be not good. Next slide. Converged network quality issues. Converged network quality issues. First thing is lack of bandwidth. Means so my traffic is coming from the inside network. Here my speed is 100 Mbps. But the data is going out when from this router, the speed is 1.544 Mbps. So it is not getting the enough bandwidth for all the traffic. Inside the traffic is 100 Mbps, but when it is going out, then traffic is 1 Mbps. So the traffic will be congested. Then packet loss. In this situation, if all three type of data, voice, video, and data traffic is moving through this single link, so some amount of the data will be lost because it is not getting the enough bandwidth to process the data. Third one, delay. Now what is delay? Delay is basically concern in the voice traffic and video traffic. Let's say this is my voice traffic. These are voice packet. This interval must be constant. So that is known as delay. The time duration between two packets. If this delay is constant, then the quality will be good. But let's say if the delay increase or delay vary, that thing is known as jitter. So jitter is basically variation in delay. Clear this concept or not?
Yeah, that makes sense.
Then last one is jitter. Packet loss due to tail drop. Now, let's assume this is your router. So this is your ingress port. Ingress means your incoming port, and this is your egress port. So these are your traffic. This is your IP data, which is coming to this serial interface or this interface. On this router, there is a queue, and in that queue, this is your packets. If this queue is full, so what will happen? The data will be here. So those data will be dropped. And this is known as tail drop. Clear this thing? So tail drop occurs when your output queue is full. There is no buffer space to put the packet in my buffer or in my queue. So the next upcoming packet will be dropped, and that thing is known as tail drop. Clear this thing?
Yeah, I believe so.
QS mechanism. In QS mechanism, we have first classification, then we have marking, third one we have congestion management, then we have congestion avoidance, then we have policing, then last one we have shaping. So these are the six QS mechanisms. Let's discuss one by one. Classification. Now classification means now in my internal network we have these three traffic: video, voice and data. If I want to give priority to these traffic, then first thing I have to identify the data first thing. To which data I have give more priority. So classification means identification of the traffic. This can be done with the help of ACL, with the help of protocol, with the help of N-bar. These are some advanced services. So for example, this video traffic is on, let's say, network 10. This voice traffic is, let's say, on 20. So on this router, I can create a ACL, and in that ACL, I can match that particular network 10. If I'm matching this particular network 10, that means I am matching this video traffic, correct? I create a access list number, network 10.0.0.0, then wildcard mask. So that means I'm calling this network 10. So network 10 means what? My video traffic. Clear? Any confusion here?
No, no confusion.
Next, marking. So once the traffic is identified, then you have to mark the packet. Marking is used to mark packet based on classification, metering, or both. So here I can mark whatever traffic I classified. I can mark that packet. This is my important traffic. This is my critical traffic. This is my normal traffic. Third one, congestion management. Now, congestion management is used to prioritize the transmission of packet with a queuing mechanism. each interface. So I can define a queue, means whatever is the video traffic that will come into the first queue, whatever is the video traffic, queue number 2, normal data traffic, queue number 3. So we can implement multiple queue. Next one is congestion avoidance. It is used to drop packet early to avoid congestion later in the network. So I can specify the limit. What is my minimum limit? What is my maximum limit on the queue? So if the device identified the data is reaching to the limit, in that case, it will give a signal to the device, don't send any packet now. And if any packet is coming, simply drop that packet, because I don't have any space to take that packet into the buffer. So this mechanism used to drop packet early to avoid the congestion later into the network. So to implement this, we have to implement what is my minimum threshold limit, what is my maximum threshold limit. Next is policing. Used to enforce a rate limit by dropping or marking down packet. So we can specify this is my maximum threshold limit. So if data is reaching to that limit, then simply drop. And next one is shaping. Shaping is similar to this, but in shaping the data will be not dropped, data will be into the buffer. Shaping. Used to enforce a rate limit by dropping, so by delaying, not dropping. By delaying packet using buffers. So shaping is used to enforce a rate limit by delaying the packet. So we can specify a limit. If the data reach to that limit, then store that upcoming packet into the buffer. Don't drop them, simply put that data into the buffer. Next, last thing, QS models. In QS, we have three models. First one is best effort. Second one is int serve. Third one is diff serve. Best effort. So by default, QoS mechanism is best efforts. No priority to any traffic. So if video traffic come first, that will go first. If voice traffic come first, that traffic will go first. Int serve. In int serve, we fix bandwidth for a particular traffic. So we reserve a end-to-end bandwidth for the particular traffic. If that traffic is not going on that particular link, no one other can use that bandwidth. Hence, that bandwidth is only reserved for that type of traffic at that time. Diff serve, we can give priority according to requirement, and there will be no reservation of the bandwidth. Clear this thing? So best effort model is basically is the by default mode of the traffic. There is no differentiation among the traffic. So by default, all traffic will get the equal priority. If you go with the benefits, it is highly scalable, no special mechanism required to configure. This is the by default. What is the drawback here? There is no service guarantee. Means if the packet drop, we cannot give any guarantee for 100% packet delivery. And there is no priority service differentiation. So let me explain this int serve. Int serve model. So let's say these are the IP phone. In the int serve model, we can define for the voice, we can define this thing. For the voice traffic, 512 kbps is fixed. So if we are doing this type of reservation, that model is known as int serve model. In this int serve model, there is a protocol used, RSVP protocol. Now RSVP is resource reservation protocol. RSVP is used for reserving bandwidth and QoS tools for a particular flow. Clear this thing? Diffs are network traffic is identified by classes. So here you have to define the classes, and based on that you can identify the traffic. You can put different policy on every hop. So maybe on one router you can give 512 kbps. In the next router you can give 1 Mbps. So there is no fixed policy. Okay. So after that, in the QoS we have some labs, but the labs are not here. Labs are into CCIE, not into the CCNP also. So this is all about the QoS and the CCNA part. According to me, everything is done. And if you want to ask, you can ask.
Nothing, just need that list of protocols.
Okay, sure. Sorry, I forgot. Protocol port numbers. So let's say IP, TCP, UDP, DNS, DHCP, FTP, Telnet, SSH, HTTP, HTTPS, NTP, SNMP, SMTP, and
What about SFTP?
SFTP.
Yeah, is that one that we have to know for this or no?
No, but it is using the same protocol, FTP. That is a secure FTP.
Right. Is it on the same? Is it on the same port though? I thought it was a different port.
Same port. Sometimes we can customize the port also. Every protocol port can be customized. It depends on like what you have implemented in your network. So IP is 0, TCP is 6, UDP is 17, DNS 53, DHCP 67, 68, FTP 21, 23, port 3. Hold on. NTP 123, SNMP 161, SMTP 25, 21, POP3 110, TFTP 69. Okay. So these are some well-known ports. If you want to identify some more ports, so you can go here. So you can follow this Wikipedia link. So everything is there. The complete list of your port numbers. Normally, you have to use only this. For the CCNA, you should know this. That's it. In your access list, access control list, normally the question will be on port number 80 or port number 23.
Oh, and I guess what confused me is apparently, according to that Wikipedia page, SFTP goes across the SSH port, so it's off 22.
That is a secure. As it can be 22 and it can be customized also. Because it's secure, that's why it is on 22, secure shell. SCP and SFTP. Okay. Any other question?
The only other thing is you're going to send us a copy of a book.
Yeah, that I have to search basically. Let me see if I have that. I have that book, but I'm not sure that is in my laptop or in my hard drive. So
Okay.
I have to search that book.
No worries. I'm assuming you'll have to file share that to us.
Okay, I got it. How much size? So I'm just uploading that book. Send that book. I think you received. Okay. Do you know how to break the password on the device, on router?
Can't say I do.
So let's discuss that part, how to break the password. Let's say on this device, I configure a password, enable password, and let's say 123, and I save this password. If I try to enter here, it is directly coming into the privilege mode folder. Let's say I configure a enable password. One, two, three. And I save this password. If I log out from this router and try to log in, it is asking a password. If I know the password, I can enter. If I don't know, in that case, what will happen? I cannot use that router at that time. I cannot configure anything. So for that purpose, you can break the password. So to break the password, your first task is you have to power on the device, power off, and then power on. Once your device is booting, you have to press three keys: Alt, Control, and pause break key. These three keys together. So once you enter these three keys, you will be into the Roman mode. So let me write the steps. Password recovery in router. Step 1, reboot device. Step 2, press Alt, Control and pause break key. Booting time. You will be in Roman mode. Roman mode means here. So here you have to type confrag. Confrag. Zero x2142. Enter. After that, you have to type reset device will reboot automatically. So let's see this thing. Confrag 0x2142. Enter. Reset. So once you enter, the device will reboot automatically. After that, you will be here. Here you can simply enable conft and whatever password is there, you can remove that password. For example, no enable password. No enable secret. If there is a secret password, then you can define a command, configure register 0x2102. You can exit from there, then router. You can save the configuration, copy, run, start. Then reload. Now device restart and will not ask any password now. So let's verify this thing. No enable password. No enable secret password.
We can't see you.
Sorry. No enable password. No enable secret. Configuration register 0x2102. Exit. Save this configuration, copy, run, start. Then reload. So once it reboot, in that case, it will not ask any password. enable. You can see it is not asking any password now. Correct? So this is the password recovery into the router. So now what is the meaning of this configuration register and other stuff? Whenever you implement any security or any password, then by default password store in configure register with default location is 0x2102. This is the default location. You can understand like this way. There is a room and this is the main lock, main door lock, which key is not here. So now what you can do, you can enter into the room through a window, and that alternate is 0x2142. That is the alternate gate, or you can say that is a window through which I enter into the device. From inside I open the lock and then I came out from the room, and now there is no lock. So if you see my previous screen, I log in with 0x2142, means I log in with the alternate route into that router, and then I define reset the device from that alternate path. So this is the router password breaking. Clear this thing?
Yeah, and is that, I'm assuming those steps are for Cisco only routers?
Sorry, Cisco? And there are some maybe some commands are changed in different models.
Oh, I see.
For example, if you have fixed port routers, for example, like 2500 series, so all the steps will be same. Instead of reset, there will be I initialized. That's it. The rest of step will be same. Instead of this reset, there will be I. I means initialize. Rest of all steps will be same. Okay. So this is from my side. Everything is done. So now do one thing. Share your screen. Let me install that software on your system. So who is having admin privilege?